Welcome back to my channel, Spilling Biology with TK, and we're back with another video. And today our video is all about development. So we're first going to start with what are the different structures that we're looking at in the first week of development. So this area right here is pretty obviously our egg. And we have some different receptors on our egg that we'll go over once we get there. This egg, formerly in biology and different science terms, what we call the oocyte. And the membrane is what we refer to as the oolemma, which is where the receptors sit, and these receptors are called ZP3 receptors. Okay? Let's go ahead and get those things out of the way. So, have our egg that comes from mom, our oocyte, and it has ZP3 receptors that are waiting for the sperm here, which I think these are pretty obvious that these are sperm. And keep in mind where this is happening, right? This egg is sitting here, and it's just been released from your ovary during your ovulation cycle. So this is over in ovulation. So that is where we drop the egg, right? So now we're dropping this egg, right? So once we drop the egg, our sperm can now come in contact with the egg. The sperm come in through the vagina, and they make their way through the cervix, and then into our uterus, and then pass to make their way up through the fallopian tube, so they can get to the oocyte. The oocyte is released from the ovary, and it's going to come down the fallopian tube. So you have your sperm coming from one end, and your oocyte or your egg coming from the other end. So they're coming together to meet, and this is that fallopian tube area that we're in, where the two are going to meet. They can meet in the uterus somewhere. They can meet at any point when once the egg has been released from the ovary, and once the sperm is in the vagina. So once this egg is dropped and we're starting our ovulation cycle, this egg can only live for about 24 hours. So once the egg is dropped and goes into the fallopian tubes, keep in mind that you're not actually going to be able to fertilize it for forever. It's only about 24 hours after the ovulation cycle happens that you're really in a place where you can have that egg be fertilized. Sperm, on the other hand, does last a little bit longer. Sperm is available for about 48 hours. So you do have to be careful. That's why it's such a big deal if you have sex with two different men in a 2-day time period, that it might toss up when exactly you got pregnant and who exactly is the father. Because if you don't know when exactly the egg was dropped, because it's hard to pinpoint at what point in the month you're going to drop the egg. You don't really know. So when the egg drops, it's kind of random. So if you're not having sex with the same person, it can throw you off. Even if you're tracking your periods with a period tracker or something like that, it still doesn't tell you the exact time that the egg's going to drop. It's going to give you a good estimation of a couple of days within the time frame where you're the most likely to have your egg dropping. And then if you have sex within 48 hours of that egg dropping, the sperm is very likely to survive and very likely to then be able to fertilize the egg because it's available to do so. This fusion of the lysosomes underneath the acrosome allow for the sperm to actually penetrate through the vessel, through the oolemma or the membrane of the oocyte. So it's going to bind here, and that's going to allow for it to burrow right inside of the oocyte. And keep in mind that the tail of the sperm does not also travel into the oocyte. It's left on the outside of the oocyte. So you have the acrosome being activated, lysosomes fuse together, and that allows for the sperm to actually make its way into the oolemma, so the genetic material can come together and we can have a baby form. So that is the first major step, first major things that are happening with the sperm. But most of the activation at this point is happening with the egg. So let's talk about that. So when we talk about egg activation, there are 3 major things that are happening with egg activation. First, we do know that the sperm is binding to the ZP3 receptor on the egg. So when that happens, that leads to calcium being released. Calcium release affects the zona pellucida and hardens the zona pellucida. So we have hardening of the zona pellucida. So why is this hardening super important? because it's then protecting and preventing other things, other sperm from binding to the egg. It's doing it by changing the environment of the extracellular matrix. That's a signal for the sperm to be like, okay, this egg can no longer be bound to. The other thing that it does is it causes the depolarization of the membrane. This depolarization of the membrane, or the lemma, is going to cause these receptors to basically fall off. It's going to cause all these receptors to disappear. So once we no longer have the ZP3 receptors there, there's nothing else for the sperm to bind to. So that's why it's not really an idea of two sperm binding to the same egg when you have twins form. Twins is more of a thing that's caused by when you have the sperm meet the egg, they immediately fuse into two different eggs, basically, so that you have two different kids forming from the same sperm and egg. That's how you get identical twins. Or you have the fertilization of two different eggs pretty much exactly at the same time. So they both go through the process, they both are made, and that's how those two kids don't look the same, because they technically don't have the same genetic material because they came from two different eggs and two different sperms. But with identical twins, they look so similar because they came from the same egg and the same sperm. They just immediately, once this fertilization process happened, they immediately split into two different sperm and egg zygotes, so that then they both go through the fertilization process and the implantation process and all those things separate of one another. It's kind of cool. But yeah, this is pretty much what's happening at the egg point to get to a place where you can't have any more sperm binding. And that is what prevents us from having a ton of kids with one single egg. The egg pretty much has its own protective measures in place. Keep in mind that the oocyte does not actually complete its meiosis process. And it is not until the sperm and the egg meet until this process is completed. So the first thing that happens once the sperm and the egg come together is that meiosis is completed, so that you can actually begin to have the zygote formation. So we first, after meiosis happens, we have cleavage of the cells. So the cells start to divide into more and more cells. And once we have that cleavage happen, compaction occurs so that you can have the cells actually coming together and starting to form a shape that we refer to as a morula, then forms a blastocyst. And as these cells are continuing to divide and all these structures are forming, the cell is traveling from the fallopian tubes further away from the ovary and into the uterus so it can attach to the uterine lining. And as this is happening, it's continuing to travel all the way down. And as it travels, we eventually get to uterus, binds to the uterine lining, and that's the end of the first week. So when the sperm and the egg, or at that point it's now called a blastocyst, get to the uterine lining and start to implant, that is how we know we are at the end of the first week. And at this point, mom doesn't even know that this has happened. She has no clue, no indications. There's really nothing going on in her body or in her life that's telling her that this is happening. I mean, she might be feeling a little bit sick because her body might be recognizing a foreign invader, because now there's sperm and eggs dividing and it's not really normal. But other than that, there's really no, not the throwing up kind of sick. I mean, she might just physically be feeling bad, a little bit like a flu or a cold or something like that. But that's pretty much it. Might be the only symptom somebody might see, but they typically see no symptoms in this first week of life. So now that we're finished with the first week of development, let's jump right into the second week. So at this point, we have a blastocyst, like I said before. And this is kind of sort of what that blastocyst looks like. It's massive cells, a huge mass of cells, but now it's created some type of, we call it a seal, or like a hole inside of the cell, and it's full of fluid. And this is going to allow for this first place of separation that we're going to have in the cell, to allow for the area that actually attaches to the uterine lining versus the area that's actually going to be responsible for making the embryo. This part is going to be play more of a role with the placenta, and we'll talk about that in the next couple of minutes. And this is going to play more of a role of actually forming your baby. And at this point, we have two kind of layers that are forming. At this point, it is called our inner mass and our outer mass. So this portion, this kind of outer piece, is kind of like the outer mass versus the inner mass. So it makes pretty much good sense. So, your inner mass, though, is going to start to divide into two different types of cells. So, this inner mass is going to start to divide into first, these are going to become epiblast cells. And these cells on the bottom, over here, all these cells are going to be hypoblast cells. The differentiation of the epiblast cells versus the hypoblast cells, that process is called forming your bilaminar plate. Or it's that bilaminar plate formation. So it's when you're forming two layers. So bi is your indication that you're forming two layers. These cells on the outside here, these cells are called your trophoblasts. And like I said before, these are the cells that are actually going to embed into your uterine lining. And when those trophoblasts embed into the uterine lining, they eventually fuse together. And when they fuse together, we call them syncytial trophoblasts. Okay? So that's kind of what's happening with the egg at that time frame it's happening, is that these trophoblasts are fusing together to become syncytial trophoblasts. So they can form kind of like a better attachment to the uterine lining. So once they all fuse together, they do that. And then you have the epiblast cells forming into epiblast cells and hypoblast cells, and that's where your bilaminar plate formation is happening. And then at the top of these epiblast cells, this is basically the top of the epiblast cells. So at the top of these cells, you have something that's forming at the top, which is called the primitive streak. And this is going to be the first thing that kind of gives us orientation of the anterior side versus the posterior side of the cell. And the primitive streak is a good indicator to let you know that you're in the posterior side of the human. So now this is going to play a huge role when it comes to gastrulation and forming that third layer that we're going to see in the third week of development. So at this point, we have two layers formed. So if you're looking at a side view here, it's kind of what this is. You would have your epiblast cells here, and then your hypoblast cells here. So I realized I didn't do an amazing job the first time we go around of explaining how the amniotic cavity came around. So I want to make sure I do a good video of it. So here we are. So we have the division of those epiblast cells, hypoblast cells. Now I kind of want to change the orientation I originally gave. So we're going to call these cells up here at the top. These cells are what we're going to call our hypoblast cells, because remember, we're at the place where we're forming our bilaminar disc. We have those two layers that are forming. So we have our hypoblast cells up here closer to our cloacal cavity that we made when we were making our blastocyst in the first place to make our cloacum. So we're going to put our hypoblast close to that layer. Epiblasts are going to be down here, lining the rest, where the majority of the trophoblasts are. So these are going to be our epiblasts. So do keep in mind that both hypoblasts and epiblasts are derived from trophoblast cells. And then the hypoblasts are going to be the cells that are more closer to your cloacum, that is in your blastocyst, and your epiblast cells are going to be down here. And why this is important, because some of these epiblast cells are going to differentiate into amnioblasts. And amnioblasts allow for the amniotic cavity to be made. So some of these cells down here are going to become amnioblasts, and as they become amnioblasts, they differentiate and allow for a cavity to form. So now we have this purple cavity that formed at the bottom, and this is our amniotic cavity. Sorry, I'm spelling that out wrong. It's called the AC right now. That's our amniotic cavity at the bottom that formed from those epiblast cells that we have right here. And now these hypoblast cells that we have at the top are now going to, as this amniotic cavity is formed, we also have another cavity called our chorion that's forming at the same time. And that is happening by way of the epiblast cells lining this cloacum. So your epiblast cells allow for the amniotic cavity to be formed on the bottom, and the hypoblast cells flow up the top for the beginning of the chorion formation by way of the hypoblast cells lining this cloacum. So if you made it this far, I want to again remind you to make sure you like, comment, and subscribe to the channel. And I also want to apologize for all my terrible drawings. I'm not really an artist, but I'm hoping that the visual aids are helping you guys with understanding. So as we're starting into our third week of development, and the last week we're going to cover in this video, the bilaminar disc or the bilaminar plate is what we're focused on. So that's what I drew right here. And keep in mind where this is. This is right underneath our original blastocyst that we blastocele that we formed at the beginning, and the amniotic cavity that we formed in the second week of development. We're right on top of it. I know this isn't a super accurate picture, but I kind of want to give you some orientation to kind of help you out. So this is what it starts with at the end of week 2. We have 2 layers are forming, and by the end of week 3, we're going to have 3 layers forming, and you're going to have cells that have entered into this space right here. And those cells are what we're going to call our mesoderm. And what's going to eventually form our mesoderm, and this is going to eventually form our endoderm, and this is going to eventually form our ectoderm. So let's go ahead and label these cells as we know them so far. So we know that these are our epiblast cells. Alright, and then these are hypoblast cells. That's where we're at right now. And remember, these cells on the outside, those are our trophoblast cells that will fuse together. They're called our syncytial trophoblast cells. And they play a role in that implantation phase. So at this point, we have epiblast cells. Now, epiblast cells are actually the one where we care about. These epiblast cells right now are the ones that are at our primitive streak. So our primitive streak is actually where we're going to start. Our primitive node is going to form. So primitive node. So remember, we had a streak out here, right? That was our line of cells to let us know we're at the posterior part of the cell. Then we have a little bump form, and that's what we call our node. That lets us know that where the cells are going to start. And then we have a groove form. So that starts a groove, letting us know that the cells start to invaginate or go into the plate that's formed here. Then it starts to form a pit. And that pit kind of goes into the cells to allow for you to open up. It kind of just allows for a hole. So now our epiblast cells have a way to get into this space between the epiblast and the hypoblast. And there's not really a space there, but it's the fact that the cells are now funneling in, that they're forcing a space, right? So now these epiblast cells can now force their way into this space, and as the cells force their way through the grooving process that's now been formed at this point, we can now call these cells mesoderm cells. So now we have epiblast cells, hypoblast cells, and mesoderm cells. And these mesoderm cells are going to play a huge role in making things like our muscles and skin, and also play a role in forming our vertebral column, depending on where exactly they end up. So they can form 3 different forms of tissue that these mesoderm cells form. So they either form your dermatome, your myotome, or your sclerotome. So those are the 3 things that mesoderm form. I probably should have put those in orange. I apologize about that. So those are the 3 things that mesoderm forms into. So your dermatome is obviously like your dermis and stuff like that. Myotome is your muscles and those types of things. And then your sclerotome actually is responsible for making the vertebral column that goes around the notochord. And that's another thing that's happening at this point, is that your neural tube and notochord formation and all those things are happening. But that's more neuro and the nervous system development. But keep in mind that is happening around the 3rd week of development. And the major thing that happens in this 3rd week is that you have this pit formation, and then you have the mesoderm traveling in, and that process is called gastrulation. So gastrulation is the formation of those 3 layers. So 1st week, fertilization. 2nd week, bilaminar disc formation. 3rd week, gastrulation. If you can remember those major things, major overarching points for each one of the weeks, and then be able to break them down into detail as you talk about them and go through them, I promise you everything related to the first 3 weeks of development you will get and you will be able to work out.